Okay, this video is going to be about graphing systems of linear equations. So it's a system when you're given these two equations, and basically what we're trying to do is find where they intersect, where they cross. So let's see here. Let's first graph the blue line, and we end up getting, let's see here, a quick review of graphing. We have our y-intercept at -4, which is 1, 2, 3, -4, and our slope is 2, which is the same thing as 2 over 1. So then I would just rise 2, run 1, rise 2, run 1, rise 2, run 1. And I'm going to continue this pattern until I get a good picture of what my line should look like. Okay, it looks about there. Okay, and let's see here. Let's try the the orange one now. Looks like the orange one has a y-intercept of +1, so we're going to just go to the graph at +1, and a slope of -3, which is the same thing as -3 over 1. In which case, I'm going to go then down 3, because it's negative, and to the right 1. Down 3, to the right 1. I can also do the exact opposite, up 3 to the left 1. Okay, and that's saying the exact same thing. And we can see that these dots are going to make this line here. Okay, so now solving the system, finding your answer, is just where the two lines cross. And we can see that it's this point right here. And that point looks to be about when x is 1, y is -2. So this coordinate point is at 1, -2. So then our answer, or our solution, is 1, -2. It's a coordinate point. Okay, let's try one more, and this next one we're going to end up dealing with fractions. Okay, so let me kind of re-erase this, and let me resketch my graph. Right, x and y axes. Okay, and that should work out. Alright, so just going to move over here, and here are my two other equations. Now notice they're not set up in a y equals. So that means we have to solve for it. Alright, well, let's see here. In order to solve for y, we need to get rid of the 5x here by subtracting it on both sides. And let's see, this becomes a zero pair. We're left with -4y is equal to 3 minus 5x. Okay. From there, we have -4 times y, so we need to divide both sides by -4. Now that's the same thing as dividing each piece by -4. So that becomes a unit fraction, and we're left with y is equal to a -3/4, plus we have minus a negative, so that's going to be plus 5/4 x. And so that's our first equation. Okay. Let me adjust this just slightly. All right, let's solve for the next one. We want to get y equals something. So same idea. Want to subtract 3x on both sides. We'd have 2y is equal to, this is a zero pair, is equal to 15 minus 3x. Alright? Divide by 2 on both sides, which means divide each piece by 2, and we have y is equal to 15 halves minus 3 halves x. Okay, and so these are my two equations that I'm going to graph. Okay, so let's graph them. Okay, here's my graph. I'm going to rewrite those equations right next to it. So we have y is equal to, whoa, excuse me, sorry about that. Y is equal to a negative 3/4 plus 5/4 x. And if you wrote it the other way around, like have it 5/4 x minus 3/4, that's perfectly okay. Right? It's commutative. You can flip it around and it's no problem. Okay, let's see. The next one was y equals 15 halves minus 3 halves x. Okay, so we need to graph these. Let's start with the purple one. So we have, it looks like we have a y-intercept of negative 3/4. Well, negative 3/4 is just 3/4 of the way to 1. So here's 1. Negative 3/4 is right here. Okay. And our rise over run, our slope, is 5/4. So I would rise 5. And notice when I rise 5, where it's going to end up. We're basically rising 1, it's going to end up at 1/4. 2, end up at 1/4. And notice it's the same distance from that tick mark. It's the same distance from the tick mark. Okay, so that's 2, 3, 4, and 5 is going to be about right here. Okay, and so then from there, we need to run 4. In which case, 1, 2, 3, 4. So 1, 2, 3, and 4. And it's about right there. I can also go the other direction. So down 5, 1, 2, 3, 4. And I'm going to get off my graph a little bit. And to the left, 4. And that should be about right here. And so, let me adjust this so everybody can see okay. So from there, we can connect our line. Okay, and that's the line, that's the purple equation. Okay, so now we have the green one. It says that we have a y-intercept at 15 halves. Well, 15 halves, that is the same thing as 7 and 1/2. So I would just go up 1, 2, 3, 4, and I'm going to be getting off my graph 5, 6, 7 approximately, and 1/2. Okay, I just kind of eyed it. And so then we have a slope of negative 3/2. I'm going to go ahead and extend this so we can see how this line is working and how the slope ends up working. Okay, and so we have 1, 2, 3, 4, 5, 6, 7 and a half approximately. Okay, so our slope is just down 3 over 2. Down 3, 2, 3, and notice I'm still in between, halfway in between two tick marks. And over 2. 1, 2. And there should be a point right there. Keep doing this. 1, 2, 3, and over 2. Should be about right there. If you keep doing that, you should end up getting a line that looks somewhat like this. Alright, so now the solution is the point where they intersect, which, let's see, it looks to be about 1, 2, 3. 1, 2, 3. It kind of looks to line up there. And so this is 3, 3. And anytime we end up graphing, it should end up being something easy to tell. Otherwise, there's not really a point in graphing. Okay, so our solution then, is, or our answer is 3, 3. Let's see if that's true. So I'm going to plug this back into my original equation, and if you recall from the solving, okay, if we check these out, I'm just going to use those. So one of them was 5x minus 4y, so 5x when x is 3, so 5 times 3, minus 4 times when y is 3. Does that equal 3? Well, let's see here. That's 15 minus 12, which in fact equals 3. 3 equals 3. That's a true statement. Okay, so that one works. Now we want to check the other one. It's possible that it won't work in the other one, but let's see. So the other one is 3x, so 3 times 3, plus 2 times y, and when y is 3, equals 15. And let's see here. So 3 times 3 is 9, plus 3 times 2 is 6, equals, 15. And 9 plus 6 does make 15, so 15 equals 15, and that's a true statement. And that's how you would solve by graphing.